Module 10, Decision Making. Lesson 1, Decision-Making Frameworks. Decision-Making Frameworks. Decision-making frameworks are structured approaches that guide analysis, evaluation, selection of options. They are vital for businesses because they help simplify complex decisions and ensure consistency in achieving desired outcomes. Rational decision-making model. A systematic approach emphasizing logical progression, identifying a problem or opportunity. Criteria for any solution are established, such as scalability, affordability, and compatibility. Brainstorming sessions generate potential solutions, including upgrade or adopting entirely new solution. After evaluating, the most suitable option is selected. The essence of rational decision-making. The rational decision-making model operates on the principle that decision-making should be a deliberate, thoughtful process. By following a series of structured steps, businesses can minimize errors and bias, leading to more effective outcomes. Benefits of the rational decision-making model. Reduced bias relies on data and structured processes to minimize personal biases. Informed decisions. Decisions are based on thorough data analysis. Consistency provides a reproducible strategy for decision-making, ensures consistency across large organizations. The 7 steps approach of the rational decision-making model. Step 1. Identifying the problem. The first step is about clarity, defining the problem that needs solving. This involves recognizing an issue, understanding its nature, and determining its impact on the organization. A clear problem statement helps in aligning the decision-making process towards a precise goal. For example, a company may identify that its customer retention rates are falling due to inadequate customer service. Step 2. Gathering information. Once the problem is identified, the next step involves collecting data relevant to the issue. This could include customer feedback, employee input, operational data, and industry benchmarks. Gathering comprehensive information ensures that decisions are grounded in reality and not just hypothetical scenarios. Step 3. Identifying alternatives. With the problem defined and data gathered, brainstorming potential solutions is next. This stage encourages exploring various options, considering even those that may initially seem out of scope. Creativity in thinking broadens the potential for innovative solutions. Step 4. Evaluating alternatives. Each identified alternative is analyzed in this phase. The evaluation is based on criteria established from the gathered information. These criteria could include cost, time effectiveness, resources required, and potential ROI. This step ensures that each alternative is scrutinized against practical and strategic metrics. Step 5. Choosing the best alternative. After evaluating each option against the criteria, the best solution emerges as the one that most effectively addresses the problem and meets the set criteria. This decision is made through a comparative analysis of the potential benefits and drawbacks of each alternative. Step 6. Implementing the decision. Implementation involves putting the chosen solution into action. This step requires detailed planning, allocation of resources, and setting timelines. Effective implementation is crucial as even the best decided solutions can fail due to poor execution. Step 7. Monitoring and feedback. The final step is to monitor the outcomes of the implemented decision and gather feedback. This stage is critical for learning and continuous improvement. Monitoring allows for adjustments and corrections in real time, enhancing the solution's effectiveness. Challenges of the rational decision-making model assumes complete information. Not always possible in dynamic business environments. Time-consuming can hinder quick decision-making when rapid responses are needed. Decision matrix analysis definition. A structured framework for systematically comparing options against set criteria. Also known as grid analysis or PUGH matrix. Purpose organizes data into a visual format, provides a quantitative basis for selecting the best solution. Decision matrix example. Scenario: reducing long wait time in a restaurant. Options to tackle. First, customers waiting for the host. Customers waiting for the waiter. Customers waiting for food. Customers waiting for the check criteria and waits. Customer pain, weight 5. Ease to solve, weight 2. Effect on other systems, weight 1. Speed to solve, weight 1. Scoring system, high, 3. Medium, 2. Low equals 1. Outcome, customers wait for host, scored highest. Indicates this issue should be addressed first. Steps in decision matrix analysis. 1. Define the problem and options. Clearly identify the problem. List all potential choices. 2. Establish criteria and weights. Determine factors affecting the decision. Assign weights based on importance. 3. Score each option. Evaluate how well each option meets each criterion. Use a consistent scoring scale, e.g., 1 to 10. Calculate weighted scores. Multiply scores by corresponding weights. Sum the weighted scores for each option. 5. Compare total scores. Highest total score indicates the optimal choice. Benefits of decision matrix analysis. Objectivity, quantitative scoring reduces personal bias. Comparability facilitates equal comparison of multiple options. Flexibility, adaptable to any number of options and criteria. Limitations of decision. Matrix analysis. Subjectivity in weighting weights may reflect individual biases. Challenges with qualitative criteria. Difficult to quantify complex or subjective factors accurately. Decision trees. Definition: a visual diagram mapping out possible actions and their outcomes. Purpose: breaks down complex decisions into manageable parts. Offers clear visualization of choices and consequences. Key components of a decision tree. Root node: the initial decision or problem that needs to be solved. Branches: represent the different actions or decisions that can be taken. Decision nodes: points where further decisions need to be made. Outcome nodes: indicate the potential results of each decision. How to build a decision tree. Identify the problem. Define the main decision to analyze. Identify possible actions list. All potential courses of action. Build branches. Draw branches for each action and subsequent outcomes. Assign probabilities and values. Use data or expert opinion to estimate. Assign expected values, e.g., costs, profits. Evaluate options. Calculate expected values for each path. Identify the path with the highest expected return. This image shows a decision tree diagram for a product launch strategy with two main branches, no testing and market testing. The diagram illustrates potential outcomes, expected values, and payoff calculations for a product launch based on different strategies. Key components: product launch strategy. The first decision is whether to proceed with no testing or conduct market testing before launching the product. No testing branch. If no testing is conducted, there are 3 possible outcomes: a successful launch, a modest launch, or a poor launch. Probabilities for successful, modest launch, or poor launch and payoffs for each outcome. The expected value without testing is $28,500, market testing branch. If market testing is done, it incurs a cost of $35,000 and 2 potential testing outcomes. Positive outcome, 65% probability. Negative outcome, 35% probability. These outcomes lead to 3 possible states of launch success: successful, modest, or poor, for each testing result. Positive outcome, 65% probability. After a positive testing outcome, the probabilities for a successful launch increase. After a negative testing outcome, the launch probabilities are estimated as well as the overall expected value for market testing. Payoff table. In the bottom left, a table shows the payoffs for different states of nature: successful launch, modest launch, poor launch. The decision tree helps compare the potential financial outcomes of launching the product without testing versus the outcomes after conducting market testing. The goal is to determine the most profitable or least risky strategy based on these probabilities and payoffs. Advantages and limitations of decision trees. Advantages: visual clarity, simplifies complex decisions into an easy-to-understand diagram. Quantitative analysis, uses probabilities and values for objective comparison. Flexibility, applicable to various decision-making scenarios. Limitations: complexity, can become unwieldy with too many variables. Uncertainty, difficulties in accurately assigning probabilities and values.